All right, so welcome back to our second recorded lesson here. So hopefully you guys had a pretty good class today. Hopefully we have a pretty good grasp on functions and what they look like and what they mean. Today we're going to take a next step here, start talking about some domain and range. So these are words that you've used before, probably started back in Algebra 1 and then again Algebra 2. So again, this is something that we're just going to kind of review a little bit, and we'll be able to come up with a good, solid definition, and then maybe look at some more advanced examples this year. But really, we just want to have a really good understanding of what they are, how to find them, and stuff like that. All right, so let's start with some definitions. So the domain. So maybe last year you said like the set of all x values or something like that. So that's not bad. So the domain is the set of all input values. I'm going to use the word input that produce a real output value. So I'm going to try to avoid just saying the set of all x values, because in pre-calc, a lot of times x is the input, but we might have t as an input variable, or c or v. It doesn't necessarily mean the x values, but the input values. What are we plugging in? So we can plug in a number, and it gives us a real value back out. It's not undefined or anything like that. So then range is the set of all output values. So it's a set of all output values that come from where? So it's the set of all output values that come from our domain. So the set of all output values that correspond with the domain. Okay, so domain, what values can I plug in that produce a real number back out? In range, what are those output values that are produced from those input values? All right, so let's go back and talk about our cricket problem from our first lesson. Okay, so if you don't remember the specific, that's okay. But with our cricket problem, remember, we were counting the number of chirps in 15 seconds, and then we added 20, we added 40, and that gave us the temperature. Okay, so let me write that down. So count the chirps in 15 seconds plus 40, and that gave me the temperature. Okay, so that was our function. The specifics, not super important here, but that's what we have. So I want you to take a minute, and I want you to go ahead and pause the video, and I want you to see if you can come up with the domain of this function and the range of this function. Okay, so the domain is talking about our input values. So if you remember, our input values was the number of chirps, and then the output value would be the temperature. Okay, so I want you to pause the video here and see if you can come up with domain and range. Don't worry about notation yet, we'll talk about that in a second. But what are the possible numbers you can plug in for chirps, and what are the possible numbers you can get out for temperature? So ready, pause. Okay, so what did you come up with for domain? So what could the possible number of chirps be? So could you have negative numbers, a negative number of chirps? Nope. Could you have 0 chirps? Sure. Could you have positive chirps? Yep. Could it be a really, really, really big number? Yes, absolutely. Okay, so I'm just going to start. This is not great notation, but I just want to write it down. So the domain, number of chirps, is 0 or greater. So it's okay to count 0 chirps. Crickets aren't chirping. It's okay to have really big numbers. So there's my domain. So then what's my range? So temperature is what's being represented by the output values. So what is the smallest, lowest temperature that I can get? So is it 0? Well, think about what my function said. We take the number of chirps and add it to 40. So what's the lowest number of chirps? Well, that'd be 0. So 0 plus 40 would be 40. So that means that 40 is the lowest temperature that we could have. Okay, and then is there any limit on that? Well, if there's no limit here, you know, those values keep going up and up and up. Then if we keep adding 40, that's going to get bigger and bigger. So 40 or greater is going to be my range. Okay, and again, this isn't the notation that we want to use, but that's good enough for right now. So hopefully that makes some sense. If not, make a note and we can talk about it. But 0 or greater for the domain, 40 or greater for the range. All right, so before we look at more examples here, and we'll do a ton of examples today, I want to talk about the notation that we're going to use. So some of this notation you probably used last year. Some of it might be brand new to you. So let's go ahead and talk about 2 different types of notation that we're going to use. So the first one is called interval notation. And then the second one is called set notation. Okay, so let's go ahead and use the example of the crickets to give us something to look at with interval notation and set notation. So with interval notation, you might remember using some parentheses and brackets to describe intervals last year. So first thing is, what is the variable that I'm using for domain and range? So depending on what your input value is, might be X or T or V like we talked about, but you're gonna need to know that when you're doing your domain and range. So let's use X for domain, and then we'll say my range is f of x, the output values. So this symbol, we need to talk about this guy here. So this guy, I'll try to draw it a little bigger. Kind of looks like a lowercase c with a line coming through. So this guy, his name is epsilon. And what we're going to use him to mean, it's a Greek letter, is contained in. That's how we're going to use him. So this means x, our input values, are contained in the set. And then we're just going to list the set, or the values, possible values that are contained for our input values. So what was it? We said we could count 0 chirps, and then we could count all the way up until forever. Okay? So my notation for this, an interval notation, would be square bracket 0, comma, infinity. Okay? Now, this one, I believe you used last year. This should look kind of familiar. The key here is, what does this square bracket mean? So this square bracket means that 0 is included in the set. Okay? Because remember, we can count 0 chirps. That's a possibility. So since we can count 0, that means 0 is included in the set. Now we'll look at some examples where it's not included and where we'll just use a parentheses instead of bracket. Now, infinity is never included because it's not a real number. We can't ever reach it. So from 0 to infinity, those are my possible input values. Okay? So what about my output values? So for my range, we said we can start at 40. Because we said 0 plus 40 would be the first temperature, and then we go on for forever. So first of all, if my input is x, my output is f of x, depending on the function. So f of x is contained in bracket, because 40 is included. It is a temperature that we can find all the way up until infinity. So there's my domain and range for my cricket problem. Okay, so this is called interval notation. Now, let's talk about set notation. Now, as far as which one you use, I do not care which one you want to use. If you like interval notation better than set notation, that's fine, or the other way around, doesn't matter to me. But you have to be able to read both, because I'm going to kind of use them back and forth. I'll tell you some reasons I like one better than the other, depending on the problem, but you need to be able to read both. Okay, so set notation. So we start with our little squiggly bracket here. So squiggly bracket, that's our set notation symbol. So we still have to define our variable, okay? As we go on the rest of the year, and especially when you get into calculus, there's all sorts of variables out there. X, Y, Z. Sometimes you're using 2 or 3 or 4 variables in the same equation. So the first thing we have to do is define what variable we're looking at. So with domain in this problem, we're going to have X be our input. Then we're going to use this vertical bar. So this vertical bar, we're going to use the words such that. So we're going to say the set of all X values such that, and then in here, this is where we're going to use our greater than or equal to symbol. Remember, like the alligator eats the bigger number, all that kind of stuff. So in set notation, we're going to use that in set notation. So for my domain, we said 0 or greater. So I'm going to say X is greater than or equal to 0, and then close my bracket. Okay? So this is my set notation for my career problem. Set of all X values such that X is greater than or equal to 0. All right? So I want you to take a second, pause the video, and see if you can come up with what would the range look like in set notation. Okay? So remember, if you don't like making your notes messy, find a scrap piece of paper and try it. Ready? Pause. Okay. What'd you come up with? So it's set of all f of x values, those are my outputs, such that, my little vertical bar, and we're going to say f of x is greater than or equal to 40. And then close my squiggly bracket. Okay? So this is interval notation and set notation. So we're going to use both of those throughout the year. So I just wanted to go ahead and reintroduce those to you. All right? All right, new problems. So let's do some examples of domain and range. So the easiest type of problem with domain and range is when you already have a graph that you're looking at. Okay? So let's start with some examples of graphs and figure out what the domain and range is, and we'll try to do a good job of using our notation here. So first example, do a little exponential graph here. So here's my function. We'll call this function f. All right, so I want to know the domain and the range of this function. If you remember with exponential functions, there's some sort of horizontal asymptote happening here. So this graph is flattening out at 0. All right, so take a second and don't worry about the notation if you are still working on that. But I just want you to think in your head, what is the domain and what is the range? So what do you think the domain is? Is there any input value that is restricted? Can we go all the way to negative infinity, all the way to positive infinity with my input values? Remember, that's my x-axis here, and the answer is yes. We can go anywhere we want as far as my input values. There's no restrictions. So how do we write that? Well, there's two ways that we could write that. The first way is we could say x is contained in negative infinity to positive infinity. All right, so this is our interval notation. So you might like that. If that's the way you prefer to write it, then that sounds good. Or if you wanted to use set notation, you could say it's the set of all x values such that x is contained in all real numbers. So if you've never seen this symbol, it's an R, and then we just throw an extra line through it, basically. And this means the set of all real numbers. Okay? Which is the same as saying negative infinity to infinity, but when you use set notation, we'll use all real numbers. If we use interval notation, we'll use negative infinity to infinity. All right? Again, I don't care which one you use as long as you can read both. Now, what about my range? So remember, my range are all my output values. So if I'm looking at this graph, are all the output values produced? Are they all used? Are they all touched? Remember those, that's my vertical axis here. And it looks like I'm missing all my negative numbers. So it's not going to be all real numbers for my outputs. And also, I have this horizontal asymptote of 0, which means this curve is going to get really close to 0 but never touch. So if you just think about this range out loud, this would be 0 to infinity, but not including 0. Okay, so how do I write this? So if I want to use interval notation, f of x is contained in 0 to infinity. And notice I use parentheses for 0 because it is not included. So if you go back to your cricket problem, we use the bracket. The bracket meant that it was included. Parentheses means that's not included. So what this means is I'm going to hit every single number as close to 0 as I can get, but I'm never going to touch 0, so it's not included. So this would be my range. Or how would I write that in set notation? So in set notation, this would be the set of all f of x values such that f of x is greater than 0, but notice it's not also equal to 0. Okay, so there's your two notations for this problem here. All right, let's try one more graph problem. So this one, let's see if we can make this a little bit tougher. Something a little bit more interesting to look at. All right, so let's find the domain and range of this graph here. So in case you can't see, I'll throw in some extra numbers here. So both of these open circles are at 1. This jump here happens at -1, at +1. This guy's up here, we'll say he's at 4 as a value. And then this open circle's at 2, so we have a little gap happening in there. Okay, so I need the domain and the range of this function. So let's start with domain. So before we worry about notation, let's just talk it out. So remember, domain is which x values are used and which ones are neglected. Which x values don't get used in this graph. So -infinity to here. So all those values are hit. And then at -1, what's happening here? So there's this jump, but this open circle means what? This open circle means it is defined here at -1. So -1 is included in my domain. So even though that's open up there, because it's included down here, -1, we're still good to go. So -infinity to -1, and then -1 to +1, we're still good there. But then there's this gap between 1 and 2. And then once we get to 2, once we get past 2, everything's included. So with your domain, it's going to be everything here, we're good. We're still good. Uh-oh, we have this gap between 1 and 2. So how do we write that? So we're going to say x is contained in. We'll start with our interval notation here. So x is contained in -infinity all the way to -1, we're still good. All the way to +1, we're still good. But then we have a break. So -infinity to 1. 1 is included because closed, filled in dot. Now, I have a gap between 1 and 2. So between 1 and 2, it's not included, but then from 2 till forever, it is included. So I have to have a way to say this is one interval, but then there's also another interval. So the way I'm going to do that, I'm going to put a big U. So this big U stands for the word union. Just like your two things are getting married, we have a union. So this is an interval from -infinity to 1. Pause for a second, and then 2 to infinity. But if you look, 2 is not going to be included because it's an open circle. So this is going to be 2 to infinity. So there's my domain. So a little bit goofier, but if you think about what this means, it makes no sense. -infinity to 1, all the way from here to here, take a break, 2 to infinity. Okay, now the set notation version is a little bit clunkier. You might not like it as much. So let's go ahead and write it, and you can pick for yourself. So it's going to be the set of all x values such that, so how do I write this? So this is going to be x is less than or equal to 1, comma, now I got to take a break, 2 till forever. So x is greater than 2, but not equal to 2 because we have an open circle there. Okay, now, just real quick, what is this okay? What do you think about that? Is this good? So this is saying x is less than or equal to 1, which is what we have there. X is greater than 2, which I think is what we have there. So do you think this is good? So I'm going to ask you to pause and say, is this notation the same as that? Ready, pause. Okay, the answer is no, it is not okay. And how come? If you look at it in pieces, it seems like it's the same. X is less than or equal to 1, boom. X is greater than 2, boom. But look at the full sentence. What is this saying? This is saying 2 is less than x, which is less than 1. Is 2 less than 1? No, 2 is not less than 1. So this statement as a whole is a big fat lie. Okay? So you got to be careful when you string these together that if you read the entire sentence, it has to be true the entire way. So the only way we can do this here is with a comma. All right? Now, let's talk about our range for this problem. So let's just think about it. Just think about it logically. Don't worry about the notation. Which output values are hit? So this is going down for forever, so that's good. Come up here. So there's a jump here, which makes me a little bit nervous because these output values are not being hit. But if I come over to this piece, this gap is filled in by this piece of my graph over here. So these values are okay. Now there's a small issue here at 1 because these are both open circles. So it looks like 1 is not included. And then all the values from 1 to 4 and between 1 and 4, those are good. But then anything bigger than 4 is just empty. Okay? So let's think about this in words. So negative infinity all the way till 1, we're good to go. 1 is blank, up to 4, which is good, and then nothing bigger than 4. So how do we write this? So if you want to pause for a second, see if you can come up with, how would I write this in interval notation? I think interval notation is my favorite for this problem where there's a bunch of jumps. So I'm going to break this into pieces. So negative infinity all the way till 1, but 1 is not included because we have open circles. So negative infinity all the way up to 1, not included, so I use a parentheses. Union. So then I got to talk about this part. So from 1 to 4, I have all of these values, but again, 1 is not included. But 4 is included, so 4 gets a bracket. Okay? Now, you might be looking at this and saying, well, that's goofy. So you're saying from negative infinity to 1, union 1 to 4. So is it okay that these are both 1s? And the answer is yes. How come? Because what this is saying is all the values from negative infinity to 1, not included 1, because we have parentheses, and then 1 to 4, not including 1 again, because open circle, open circle. All right? So how would I write this in my set notation? So set of all f of x values such that, so x is less than or just less than 1, comma, and then in between 1 and 4. Okay, so this is a case where I'm allowed to use this full sentence because 1 is less than x, which is less than or equal to 4. That full sentence makes sense. 1 is less than x, and 1 is also less than 4. So there's my notation for that. Okay? All right, so if you can do this one, then you can pretty much handle any graph one. So the last thing I want to talk about, I'll leave you with this. If you have a graph, no big deal. We can look at it. We'll get better with the notation if you're still struggling with the notation a little bit. But what about equations? So with equations, it gets a little bit tougher to be able to just pick out the domain and range. Okay? Now, we will get better at this throughout the year once you're better at looking at an equation and knowing what the graph's going to look like. Okay? For example, f of x equals 3 over x plus 2. Now, in my head, I kind of have an idea of what this graph looks like because this is what I do. I know what this is going to graph in my head. All right. Now you learned about it last year, but maybe you haven't mastered it. Maybe you're not sure what this is going to look like as a graph, and that's okay. But here's what I want you to start thinking about when you try a couple homework problems. I want you to think about, what are my red flags? And what I mean by that is, what am I worried about with fractions? What would I plug in that would make this fraction have an undefined output? Do you remember that? What is 3 divided by 0? Well, if any time you divide by 0, that would be undefined. So what x value would make this have a bottom that's equal to 0? Well, that would be -2. So x equals -2 produces an undefined value. So what does that mean about -2? That means that -2 is not in my domain. Because if you look back at your definition of domain, your domain is the set of all x values that produce a real output. So if I plug -2 into this function, I'm going to get an undefined output, which means -2 is not in my domain. Okay? So how do I write that? That means that the domain of this function would be the set of all x values such that x does not equal -2. That's it. Why does that make sense? Because any other number you plug in here is not going to give you 0, and we're good to go. Fractions, great. Negative numbers, awesome. But if you get 0 on the bottom of a fraction, that's going to mess up your domain. Okay? Let's not worry about range right now. One more red flag. So we have a red flag, 0 on the bottom. Okay? What about this function? All right, so square roots. What are we worried about with square roots? Something that you talked about in Algebra 1 or Algebra 2. We always say you can't have a negative under a square root. Okay, now what does that actually mean you can't? I mean, you can, but it's going to produce an imaginary number, you know? So remember, our domain is the set of all input values that produce a real number. Well, imaginary numbers don't count. So think about, what can I plug in for x that would produce a positive number under here, which would be a real value as an output, okay? Or better yet, what could I not plug in? So let's just start by plugging in some numbers. So what about like -1? So if I plug in -1, -1 plus 1 is 0, square root of 0 is 0. Is 0 a real number? Yep, smiley face. So that one works. So that means -1 is in the range, is in the domain, I mean. So -1's in the domain because when I plug in -1, I get 0. 0 is a real number, okay? So what about -2? Well, if you plug in -2, you're going to get the -2 plus 1 is -1. Square root of -1, that's no good. That's not a real value. Okay? What about like -1.5? -1.5 plus 1 is -0.5. That doesn't work either. So what is my domain? I can plug in -1. I can plug in any numbers bigger than -1, but anything less than -1, I get a sad face because that's an imaginary number. So what is the domain of this function? So the domain of this function would be the set of all x values such that x is greater than or equal to -1. Because if I plug in -1, I got 0. I like 0. 0 is a real number. If you plug in anything bigger than -1, you plug in 2, you plug in 4, those are all going to be positive numbers on this square root, and so we're good to go. Okay, so 2 red flags to think about as you're doing your homework. First red flag, zeros in the denominator, zeros on the bottom. So what values can you plug in that'll give you a 0 on the bottom? Because 0 on the bottom, that's no good. And then the second red flag is negatives under a square root. Those are no good. Okay, so just worry about domain for now when we're looking at equations. We'll get better at this as we go. So for your homework, when you're doing these, think about what numbers can I plug in? Think about what your equation looks like. Think about your red flags here. Now, if you're good when you see a graph, not so good when you see an equation, what could you do if you have an equation and you don't know what it looks like? Well, how about you graph it? Okay, if you graph this function, spoiler alert, it's going to look something like that. Okay, and then maybe you'll see, oh, looking at the graph, I see that my domain is greater than or equal to -1. So we really need to be able to do it without a graph eventually. But as we get started, if you're stuck, throw it in a calculator and see what you got. All right, so good luck with this. Remember, knowledge checks, I'm happy to help you. So shoot me an email if you're struggling. We'll pick up with this the next time I see you. But try that knowledge check. Try all those problems on the homework. I'll send out a key after you guys have completed the assignment so that you can kind of check all that work, and we'll figure it out. Okay, so communicate with me. Let me know how I can help, and we'll talk to you again soon.